to Engineer's Workshop. So we're going to be working on this upper casting. This is from a Rockwell RA16, a 16-inch radial arm saw, which needed some work. I got it for 60 bucks. There were a couple things broken, but I ended up breaking this casting in trying to get off the locking lever. So let me flip this over and show you what I did and what I have to do to clean this up. This round piece actually goes in from the bottom. It's 4 1/4 inches in diameter. It has 3 machined like V-stops in here for a 90-degree cut and 2 45s. And then there's a stop pin that you can pull out and it will index into those. Then the way this was clamped was the casting is split from the top all the way down to about the last 3/4 of an inch. And then this lever on the side, which I made a new extension for. And if you notice, this is a left-hand thread. That was the cause of all the problems. This shoulder, as the end threads into this wing, it will pinch this wing shut on that and lock it in place. So in trying to remove this, I really had no idea that it was a left-hand thread. There's no reason for it to be a left-hand thread. And I was tightening it, and I was putting a lot of force on it, and ended up cracking this wing off. Well, not off, but it went from the top almost all the way through to the bottom edge. So I had this welded by a local shop, cast iron welded. I think he got it all. He was able to get it from the back side and the front side, but I've got some really hard weld here that I have to remachine this board to be a very close fit to this piece here. Now, I don't want to machine this just in its free state. I want to be able to clamp this up semi-tightly and put something in this split here to take up the clamp force so this doesn't pinch shut. And I know this isn't the best thing to do for a gauge block, but I think I'm going to use a gauge block on the back side, and I'm going to use a piece of my dead soft aluminum wire on the front and get that crack, this split blocked up here, and then that way I can get a little bit of tightening torque on this bolt here. And then I'll set everything on the flat surface on 1, 2, 3 blocks, front and rear, and do the machining of this bore. I'm going to use the rotary head feature on the K&T and do some rotary milling on this to get that weld down close to where it is supposed to be. And then I'm going to use the boring head that you saw in the last videos to do the finish cleanup of that. And if you look at this, this is a piece of Schedule 40 steel pipe, very pitted, and that came out with a pretty good finish on crappy steel. I'm sure it'll be better on the cast iron as long as it can withstand the thumping and the interrupted cut that this is going to present to it. So let's get this supported and get this back over to the K&T. I think I'll mill that off after I clean this up. Okay, that is pretty tight. I've got an indicator mounting pin and a 190 gauge block in there, jammed in pretty tight, and a flattened piece of the aluminum tie wire, hopefully backing up that gap from the front. So we'll get this flipped over now, back on the K&T. Well, it's been a shamefully long time since I've had the table of the K&T cleaned off. Still scraping evident over most of its surface. Everything's in really good shape. I've got one little pecker mark right there. not mine, from a previous owner, but let's go ahead and get the arm set back in place. Well, here's my setup. I'm sitting on 1, 2, 3 blocks that are clear of the bore so that this can go all the way down through. Clamped pretty tight with 2 clamps here, and then at the back you can get a pretty good view here of the damage that I have to clean up. And I've got this indicated in within about 1/1000. I don't think it's perfectly round anymore since the repair. I'm going to start off with my solid carbide 3/4 inch rougher finisher. It does have some damage up high, but it's got about 3/4 of an inch of good flutes. Now I'm just going to get in there and walk this diameter and slowly clean that up. I don't even think I'm going to use the power feed on the head. I'm going to crank it by hand. Now the dimension I have to work to is 4 1/4 inches on the diameter. So that is 2.25 minus the radius of the cutter. In this case it's 3/8 of an inch. So I can offset the head up to almost 1.875. I need to stay a little bit shy of that and allow some 5/1000ths or so cleanup for the boring head. So I'm going to get the indicator off and put the indicator on the table and against the side here. Just I'm nervous about this thing moving under vibration, so I'm going to try to have an indication of whether it's moving with this indicator. Got that kind of parked over the high spot, so I'm going to snug my slide gibs up here just a bit, turn the cutter on, keep indexing out until we just touch, and then I'm going to conventional mill across that. See how it sounds and keep an eye out for any movement sliding on the 1, 2, 3 blocks here. I'm also going to put just a little bit of tension on the quill so that that doesn't tend to walk itself down. Let's see how we do for some test cuts here. I'm doing about 10,000ths at a time. I'm going to go ahead and put the rotary head on. I got this on its slowest RPM, which is 1/5. of an of a revolution per minute. That's faster than I was cranking it by hand. There's a little bit of weld spatter over here. I'm going to bring it around and see if it is touching that yet. What I'm doing now that seems to be working pretty decent is I got it out close to the perimeter. I'm just walking it back and forth and bringing the quill down about 100 thousandths at a time, and then gently walking that around and deepening my depth of cut until I run out of travel on this cutter. My rotational speed is about 3 degrees every 5 seconds on the head. You could figure out what that is in RPM. Getting real close to my hold down stud on the back side. I'm going to have to switch to a different cutter at some point here. There's my progress so far. So I'm going to have to change over to a, really all that I have is a long roughing mill. It's not carbide, but it will reach down in there further, and have to run it much slower. The next cutter is a high-speed bit titanium nitride 5 flutes roughing mill, 500 RPM. We'll find the edge. Trying a 200 thousandths increment on my depth of cut. Now, even with this roughing mill, which is my longest one, I'm about an 1/8 inch short of reaching the bottom of the bore, which means I'm going to have to use the boring head to do that initial cleanup. Now, the next step is to try to get some of this undercut in this middle area from here to here. Let me show you what I plan to use to do that. Well, here's the initial results of my local milling to get this surface down pretty close to the original casting. For my next operation, I want to try to get a little bit of an undercut on this section from here to here. To do that, I'm going to use one of these cutters. Got these from Doozer. This is a D-Hart. I believe these are boring cutters, but I'm going to do a little bit of side milling with it just very gently. This is a 21.8 millimeter, which is roughly 7/8, bigger than the 3/4 inch shank, definitely bigger than the undercut. This will let me get down in, offset the head, and cut this welded surface back below the original one. I repositioned my clamps so that I could swing the head in this area right over here without getting obstructed by the hold down studs. I'm going to go until I make contact with my original cut surface. Then I'm going to walk back before the start of this weld and offset the head another, I don't know, maybe 15 thousandths. Let's give that a try. I do about another 5 thousandths and then step it on down in 200 thousandths increments. Got the boring head back in place. What I'm going to do is get the insert within about 10 thousandths of this surface and then go ahead and run it down through. I'm going to have to raise the knee and go in 2 steps because I only have 3 inches of spindle travel, and that's about 4 inches right there. So let's get a couple of pieces of cardstock and get this distance set here. Got a set of 10,000 shim stock here that I didn't end up using for my cutter grinder adjustments. So that will be my gauge to get me close to this surface. And then probably when we get down near the bottom, it's actually going to start cutting. Probably within about 10 to 12 at this point. Okay, we've got about 700 RPM. We'll do 1,000ths per revolution quill feed, and we'll run this down 3 inches and see if we make contact. I rechecked my 0 to the spindle, so I should be good there. we are cutting. We're down near the bottom then. And we're through. Five thousandths advance. I don't think we're going to be touching anywhere but near that bottom, so I'm just going to very carefully run this down faster. Edge still looks good. I'm very close to the original surface, so I'm going to go with a slightly smaller increment here. Okay, you can kind of see where it's starting to clean up in various areas and get rid of the original dividing lines where I was going in multiple passes, and that bottom lip that I couldn't reach is cleaned off. I'm going in 2.5 thousandths increments at this point to not overshoot it. I set up a little bit better pointer arrangement so that I'm not wiping over top of my lines and I can see when I'm approaching them. So that's my starting position for the initial plunge, and then a new position that's 1.25 inches down from that. Cranking this down by hand because I'm still really not touching the main portions of this. Starting to get some incidental contact higher up, so I'm taking that to mean I'm getting very close to the original bore. I slowed it down to about 600 RPM. I was getting a little bit of vibration. This is much better. And it is removing material. Dropped the knee to do a double check, make sure my centers weren't changing. And I'm trying to make a determination how close I am to of this milling to the original surface. So I've got an indicator on here. And it's evident that this bore is not round anymore. But what I'm seeing is that the surface is essentially flush with the cast iron, although there's no indication that the milling has touched the original surface. Best I can tell, I haven't changed my centers at all. So I'm going to just continue, and the slug won't go in, you know, the actual pivot won't go into the bore yet. So it must be due to the out of round. I'm gonna have to keep going until that slug just slips into place. I'm making my adjustments now. I've added a thousandths. So it's going to be a very light cut at this point, and I'm going to just keep doing my test fits until this thing just slips into place, or until I see, you know, evidence that I'm at least hitting that original cast iron surface. For the first time on this pass, I'm hearing what sounds more like cast iron in a couple places than that weld. More of a scrape, scrape, scrape than a thump, thump, thump. Yeah, you can see there I'm getting into the original cast iron surface along that bottom band, there and there. Nothing on that side, that's just the dust from the machining clinging to the surface. Maybe a tiny bit starting just there, so we're getting very close. This is actually a pretty good stopping point. I think the video is getting a bit long. 99% of the way there, we've got this, you know, starting to go into the bore. So really all we need to do is some just very, very light, like thousandths at a time, clean up boring passes to get this to where this just slips in. And I think what we'll do before we remove this from the table is do an operation that I think would be pretty difficult without the K&T, the rotary head mill, which is resurfacing this top piece. I'll obviously have to reposition the clamps. I can probably clamp on that front, that indexing piece there, because there is some weld spatter that adhered to this, and it's extremely hard. and then I can flip the casting over, re-zero it, and do the same to the bottom surface. So that'll be what's up next. But very pleased with the action of the boring head, and it doesn't appear that the insert is taking any wear, any damage from that interrupted thumpy cut, even though that stuff is very hard, especially down near the bottom. Something just seems really hard down near the bottom, but couldn't be happier with the way this has been working to this point. So that's it for now for Engineers Workshop. Thank you for bearing with me on this long project and much delayed project compared to other things that's been happening in the shop. So we'll just keep plugging away at it. Hit that like and subscribe button if you haven't. Help grow the channel. To those of you who've been members for a long time, thanks for sticking with me. And as always, until next time from Engineers Workshop here, stay safe.